Dihalogen derivative X of a hydrocarbon with 3 carbon atoms react with alcoholic KOH and produces another hydrocarbon which forms a red precipitate with ammonical cuprous chloride Cu2Cl2. X gives an aldehyde on reaction with aqueous KOH. The compound X is. The reaction sequence is as follows. The compound B CH3 CH2 CHCl2 1, 2 dichloropropane, which on reaction with aqueous KOH will give aldehyde, which on reaction with alcoholic KOH will give a hydrocarbon plus 2 KCl plus water, which on further reaction with Cu2Cl2 cuprous chloride will give a red PPT. So option D 1, 2 dichloropropane is the correct answer. Which chlorine atom is more electronegative in the following? A. Methyl chloride, B. Ethyl chloride, C. A secondary chloride, that is propane 2 chloride, and D. A tertiary chloride. Due to plus I effect of 3 alkyl group, in option D, the chlorine atom occupies the maximum charge in it. Because of maximum charge, it is more electronegative. So option D will be the correct answer. Which one of the following has the highest melting point? A. Chlorobenzene, B. Orthodichlorobenzene, C. Metadichlorobenzene, D. Paradichlorobenzene. Paradichlorobenzene molecule has symmetrical structure. It can fit well in crystal lattice. So here the dipole moment is 0. It can fit well in crystal lattice. The intermolecular force of attraction are strong. Strongest among the following intermolecular force of attraction. So it has highest melting point, option D. An organic compound A C4H9Cl on reaction with sodium and diethyl ether gives a hydrocarbon which on monochlorination gives only one chlorine derivative. So only one chlorine derivative is given, that is A. So option A is tertiary butyl chloride, B S-butyl chloride, C isobutyl chloride, D N-butyl chloride, E none of this. So when the compound tertiary chloride reacts with 2Na in presence of ether, will give a compound double the structure of this plus 2 NaCl is removed, and the compound on reaction with chlorination, one chlorine derivative will give side chain chlorination. So all methyl gives same monochlorine derivative, that is CH2Cl derivative. It is a tertiary butyl alcohol. So option A is a correct answer. Which one of these do not form Grignard reagent? A CH3F, B CH3Cl, C CH3Br, D CH3I. The CF bond, that is carbon fluoride bond energy, is maximum. To break this bond, energy required is maximum as compared with other halogen derivatives, alkyl halide. in CH3F. This fluoride is less reactive to form Grignard reagent with Mg, so option A is the correct answer. When but3 2-ol reacts with aqueous HBr, the product formed is A3-bromobut1-ene, B1-bromobut2-ene, C a mixture of both A and B, D 2-bromobut2-ene. So the compound but3 2-ol is this on reaction with H plus ion, there will be removal of water to form a compound. There will be a formation of carbocation. This on reversible reaction will give this on bromination will give a compound 3-bromobut1-ene. Nothing happens to the double bond. There won't be this carbon atom. I am not putting all the hydrogen atoms. So where there is valency incomplete, there will be a hydrogen attached. And the other compound will be plus, there will be one bromo-but2-ene. So 3-bromobut1-ene and 1-bromobut2-ene will be formed. So option C is the correct answer. In which of the following conversion phosphorus pentachloride is used as reagent? So in the reaction of ether, that is CH3 dimethyl ether with PCl5, which forms CH3Cl plus POCl3, phosphorus pentachloride is used, and the reaction of ethyl alcohol, that is primary alcohol plus PCl5, also gives an alkyl halide. This is formation of alkyl halide plus HCl plus POCl3. So both of these reaction are carried out by PCl5. Option B and C are correct answer. 1,2 dibromocyclohexane on dehydrohalogenation gives. So the structure is 1,2 dibromocyclohexane on dehydrohalogenation, that is removal of 2 HBr, will give a cyclohexadiene. As it is on 1 and 2, bromine is attached to 1 and 2 position, the double bond will be here and here. So cyclohexadiene is formed, option A. Ethyl orthoformate is formed by heating with sodium ethoxide. So when sodium ethoxide, that is C2H5ONa, reacts with carbon attached to 3 chloride atoms on heating, will give ethyl orthoformate. The structure of ethyl orthoformate is C2H5O, C2H5 plus 3 NaCl is removed along with it. So option A is the correct answer. Wurtz's reaction of methyl iodide yields an organic compound X. Which one of the following reaction also yield X? Wurtz's reaction gives ethane, that is CH3I plus Na, in presence of dry ether will give C2H6 plus NaI. This is not a balanced reaction. Similarly, ethyl chloride reduced with lithium aluminum hydride also gives ethane, that is reaction of alkyl halide plus hydrogen. This is hydrogenation reaction in presence of lithium aluminum hydride will give ethane plus HCl. So option B is the correct answer. Which one of the following is example of SN2 reaction? For SN2 reaction, mostly the primary alkyl halide goes SN2 reaction mechanism. For SN1 mechanism, there is tertiary and more or less secondary alkyl halide goes through SN1 mechanism. So for SN2 mechanism, we have to find the primary alkyl halide. There is only one primary alkyl halide. So option A is the correct answer. An isomer of C3H6Cl2 on boiling with aqueous KOH gives acetone. Hence the isomer is. So the structure 2,2 dichloropropane from this on reaction with aqueous potassium hydroxide, boil it, will give an alcohol which is unstable, a diol. So option A is the correct answer, as this unstable product will give acetone on rearrangement of the alcohol group. Which one of the following is an appropriate set of reactant for the preparation of 1-methoxy-4-nitrobenzene? So compound A reaction and the B reaction, we have to find which of this will form 1-methoxy-4-nitrobenzene. Aromatic halides cannot be used in Williamson ether synthesis. However, if strong electron withdrawing group at ortho and para position are present, the synthesis may takes place. Example, when bromonitrobenzene reacts with CH3ONA will give a methoxynitrobenzene, and the compound on reaction with alkyl halide heating undergo SN2 mechanism and form methoxynitrobenzene. So both A and B are suitable for formation of 1-methoxy-4-nitrobenzene. The odd decomposition of carbon chlorine bond form A2 free ion, B2 carbonium ion, C2 carbonium carbon ion, D a cation and an anion. So the reaction of the odd decomposition of carbon chlorine bond forms. So RCH2Cl on heterolytic bond fission will form a cation and an anion. Chlorine is more electronegative than carbon, by which it forms anion, and a hydrocarbon forms cation. So option D is the correct answer. In which alkyl halide SN2 mechanism is favored maximum? SN2 substitution nucleophilic bimolecular order different alkyl halide. That is, for SN2 mechanism, primary, secondary, then tertiary favors the reaction. And for SN1 reaction, the order is tertiary favors the first, then secondary, then primary. So option A, that is primary, will favor SN2. Among the following, one with highest percentage of chlorine is. So the percentage of chlorine is calculated by mass of chlorine divided by mass of organic compound into 100. So the chloral, that is the structure CCl3CHO, is equal to mass of chlorine 106.5 divided by mass of the compound 147.5 into 100 is equal to 72.20. Similarly, we can find with pyrene, which is CCl4, and the CCl4 pyrene has mass percentage of chlorine 92.20, and gamaxane, which is C6H6Cl6, So on 213 divided by 291 into 100 for gamaxine will give 73.19%. And then comes polyvinyl chloride, which is ethylene chloride. So maximum is for pyrene, option B. Replacement of chlorine of chlorobenzene to give phenol requires drastic condition, but chlorine of 2,4 dinitrochlorobenzene is readily replaced because A. Nitro make ring electron rich at ortho and para position. B. Nitro withdraws electron from meta position. C. Nitro donates electron at meta position. D. Nitro withdraws electron from ortho and para position. So the structure of dinitrochlorobenzene on reaction with alkali, chlorine easily replaced by OH or hydroxy group. And for chlorine requires a pressure and temperature for the replacement. This is because NO2 group withdraws electron, as it is a strong electron withdrawing group. Electron withdrawing from ortho and para positions. So option D is the correct answer. Which one of the following compound does not undergo nucleophilic substitution reaction? A. Vinyl chloride, B. Ethyl bromide, C. Benzyl chloride, D. Isopropyl chloride. As a result of resonance and various resonating structures, the carbon chloride bond acquires some double bond character. Hence, vinyl chloride does not undergo nucleophilic substitution reaction. Option A. The hybridization state of carbon atom in the product formed by the reaction of ethyl chloride with aqueous potassium hydroxide is. So when ethyl chloride reacts with aqueous potassium hydroxide will give an ethyl alcohol plus KCl. So this carbon is sp3 hybridized and this one is sp3 as well. So option C is the correct answer. What would be the product formed when 1 bromochlorocyclobutane reacts with 2 equivalent of metallic sodium in ether? It is example of Wurtz's reaction. So the compound reactant is 1 bromo 3 chlorocyclobutane on reaction with sodium and ether will give a compound through intermediate in which chlorine will withdraw these electrons and the bond will be formed. So option D is the correct answer. The bond is the bridge bond. Among the following molecule with the highest dipole moment is CCl3 have one chlorine atom which is more electronegative, so it will have the highest dipole moment as it get cancelled in the remaining three and is least in CH3Cl, it is highest. So option A is the correct answer. Hydrolysis of trichloromethane with aqueous QH give A. methanol, B. acetic acid, C. ethanol, D. formic acid. So the reaction of methanol with aqueous QH will give an unstable compound. There will be removal of water molecule and a ketone with alcohol hydroxy group attached to the same carbon atom, that is enol, is formed. Option D formic acid. Fluorobenzene can be synthesized in the laboratory. A. By heating phenol with HF and KF. B. From aniline by diazotization, following by heating the diazonium salt with HbF4. C. By direct fluorination of benzene with fluorine group, fluorine gas, that is F2 gas. D. By reacting bromobenzene with NaF solution. So it is prepared by reaction of aniline in presence of NaNa2 plus HCl will give diazo salt. On further reaction with HbF4, it gives this compound where chlorine is replaced. This on further heating will give fluorobenzene plus nitrogen gas is released plus BF3. So option B is the correct answer. Which one of the following haloalkane is most reactive? A 1 chloropropane, B 1 bromopropane, C 2 chloropropane, D 2 bromopropane. The alkyl halide are highly reactive. The order of reactivity is iodide, then bromide, chloride, and then fluoride. Nature of halogen atom. And for alkyl group, it is tertiary, then secondary, then primary. Thus, 2 bromopropane in the given option is the correct answer. Alkyl halide react with dialkyl copper lithium reagent to give alkene, B alkyl copper halide, C alkane, D alkenyl halide. So when R2CuLi, that is alkyl copper lithium, on reaction with R-X alkyl halide will give R bond plus RCu plus LIX. So alkane, that is option C, is the correct answer. Reaction of trans 2-phenyl 1-bromocyclopentane on reaction with alcoholic QH produces. So this reaction produces a cyclopentane. This is the first position, second, third, fourth, and fifth, of which bromine is attached at first position and a phenyl group is attached here, which on reaction with alcoholic KOH undergo dehydrogenation, which affects the first position. Here is hydrogen and the double bond is formed here. So 3-phenyl cyclopentene is formed. It is anti-elimination reaction. So a hydrogen atom from second carbon cannot eliminate as it is in syn position rather than hydrogen atom at fifth carbon position. So option D is the correct answer. Which of the following statement about benzyl chloride is incorrect? A. It is less reactive than alkyl halide. B. It can be oxidizing to benzyl halide by boiling with copper nitrate solution. C. It is a lacrimatory liquid, and answer Bilstein test. D. It gives a white precipitate with alcoholic silver nitrate. So benzyl chloride are far more reactive than alkyl halide towards nucleophilic substitution reaction, due to the reason that carbocation formed after the removal of the halide ion, this is the alkyl benzyl chloride. So after the removal of the halide ion, the stabilized due to resonance. So this positive ion keeps on changing the position. There will be 4 resonating structures. So option A is the correct answer. Among the following, the one which reacts most readily with ethanol is A. Para-nitrobenzyl bromide, B. Para-chlorobenzyl bromide, C. Para-methoxybenzyl bromide. D. Para-methyl benzyl bromide. Due to presence of electron-rich methoxy group, which shows plus I effect at para position, the polarity increases on CX bond, by which it becomes more reactive towards nucleophilic attack of ethanol. Paranitro and chlorobenzyl bromide are electron deficient group, decreases the polarity of CX bond. Hence, by them, it becomes difficult to react with ethanol due to less polarity. Methyl group is less electron rich than methoxy group. So option C is the correct answer. Toluene react with excess of chlorine in presence of sunlight to give a product which on hydrolysis followed by reaction with NaOH gives. So toluene on reaction with Cl2 in presence of sunlight will give CH2Cl side chain chlorination plus HCl, which on further reaction with more chloride will give CCl3. CCl3 on reaction with 3NaOH will give COH thrice plus 3NaCl. COH thrice attached to benzene ring will get converted to benzoic acid by dehydrogenation, which on further reaction with NaOH will give COONA plus water. So option B is the correct answer. For the following cyclobromide, the reaction A is formed. So the product A is when a cyclopropane attached to bromide on reaction with magnesium plus EtO2, that is diethyl ether, will give Grignard reagent MgBr. So which on further reaction with carbon dioxide and hydronium ion will form cyclopropane benzoic acid attached to cyclopropane. So option A is the correct answer.